as well. So these are level 2 problems. Which is more acidic? So we have phenol and cyclohexanol. And what you should do is draw the conjugate bases of both of these so that we can look at what the structures are and what might be stabilizing them. So we don't forget to draw conjugate bases. We also don't forget to draw resonance forms. The conjugate base of cyclohexanol is the alkoxide on the right. We cannot move the electrons from the oxygen on that alkoxide, which is why I have the X over the blue arrow. But the alkoxide of the phenol, which is called a phenolate, we can move the electrons to make resonance forms as shown. We've got a bunch of resonance forms we can show. So we can say, oh, the phenol is going to be more acidic. In this case, it's much more acidic. pKa of cyclohexanol is about 16. pKa of phenol, which I've asked you guys to memorize, is about 10. And so you say, oh, the phenol is more stable because of, and you should identify one reason, so it's resonance. But there are other reasons why you might say this, and they're actually correct. You might say, for example, that the oxygen of the phenol, the O minus, is attached to an sp2 carbon, which is more electronegative, and so there's an inductive effect there. You might say that apart from resonance, that there is a hybridization effect there because the oxygen is partly hybridized as sp2, and so there's a hybridization effect on the oxygen. You might say all of those. Pick a resonance. That's the answer that organic chemists typically like. And so look for stability arising from the element effect, the resonance effect, hybridization effect, or inductive effect. We look at all of those and we decide, oh, this is a resonance effect, even though there are other effects going on here. And so there's no hybridization effect, by the way. We're losing a proton from, no element effect. We're losing a proton from oxygen in both cases. So consider that acid-base equilibrium, draw on the missing components. You folks are supposed to be stopping this and drawing in the components, and I'm just going to, oh, I don't have the answers here. You guys have to write your own answers. Terrific. Go ask your TAs or SIs or anybody else how to answer these questions, but you should be able to handle all of them.